a number of you who have tuned in usually see me at the other end in the panel, but my name is Pamela Howard. I'm the Senior Technical Advisor here, and I'm standing in as your host because Kira and Carol are unfortunately both unavailable. So bear with me. If you've missed any of our series of webinars, which have been running now since 2020, you can view them all on demand right here on our YouTube channel, or through our Learning Hub at www.proctorgroup.com. To date, our webinars have had over 116,000 views, and this is our second webinar of 2023. You can also now register for our online members area. Now in there, it's a great resource because you can access product information libraries and get personalised CPD certification. All our webinars are in there, and also our free online U-value and condensation risk calculators there. And that allows you to use that and submit that to the technical team here for review. As always, you can also request from our website and by email any product samples that you wish, literature, arrange any follow-up meetings to discuss any specifics of your projects, or to book one of our range of REBA assessed CPDs covering a range of topics which are constantly expanding. These can be done either face-to-face with our team of experts across the UK, or we can also do them online. Today, we are trying something new. Rather than having a presentation and then the Q&A, we're opening the floor to you guys out there. Anything and everything related to APG products, go for it. Ask us whatever you want. You can ask any questions on our range of products and solutions, spanning everything from ground gas to roofing underlays and absolutely everything in between, membranes, acoustics, etc. And a team of experts between us all, we'll do our best to answer your questions, and we have decades of experience between us all in a number of different sectors within the construction industry, not just with Proctors. We've received some questions by email and YouTube already. There's a few coming in through Twitter and direct messaging, etc. But please do send them in to us at webinar@proctorgroup.com. DM us, see, I'm not down with Twitter, but DM us on Twitter @proctorgroup, or just type them into the YouTube channel and we'll get them answered as best we can. So bear with me. This is my first time trying to juggle this lot as well, but bit more comfortable answering the questions rather than fielding them, but I'm sure between the lot of us we'll manage just fine. So without further ado, because this is all about you guys asking us, I will introduce our panel for the day, all faces well recognised to people who tune in to us. So we have got Ian Fairnington, our Technical Director. Morning, Ian.
Morning, Pam. Morning, everybody.
We've got Will Jones, who is Head of Business Development.
Morning, Pam. Morning, everyone.
We've got Adam Salt, who is our Business Development Manager for North, but we'll go into all areas, I'm sure.
Thank you, Pam. Morning, everyone. Yeah.
And finally, we've got Jay Finch, who is Specification Manager for London, does a lot with facade engineering and architect specification there. Morning, Jay.
Morning, everyone.
Now, I hope I got everybody's names right. If I didn't, it's personnel. I got it from the website. Okay, let's go in. We've got a few questions, as I say, coming in there. So let's find the first one here. We've got one. Jay, can I come to you for the first one? Is that okay?
Okay.
One here from James Wilson. I've seen on your website that you have a membrane which is airtight, yet moisture neutral. How does this work?
I wish I could answer it better. I get asked this question almost every day, and I apologise to Ian because he'll answer it way better than I can, as you would, Pam. But it's a science that it makes my head spin in reality. But essentially, we have a membrane called Wraptight, you're right to identify it, which essentially splits moisture or vapour and air into two very different categories. They are fundamentally really different elements. So through a molecular process, it allows that moisture to pass through it, but somehow in all the great weirdness of science, it stops the air from passing through. So Ian, you can qualify this later. But in the old days, you know, if you're familiar with construction, you would have used traditionally something like a vapor barrier or an AVCL, which works very differently. So our Wraptight membrane that you've identified actually encourages that neutral passage of moisture, allows that building to breathe and exfiltrates all the moisture out, but keeping all the nice, warm, dry air in. just as a little aside to that, when you're looking at achieving very low U values, you can put that membrane further out through the wall assembly. And certainly if later on, I don't know how your wall's being constructed, but get in touch and we can give you some advice, because by moving that air tightness out through the wall, you can actually have some really positive effects in minimizing the amount of installation that's required. So one small membrane, really amazing in its science, but can have some really positive knock-on effects later on. So feel free to get in touch. We'll give you some more detail on that.
And that's pretty good. Ian, is there anything you want to add into the science of wrap tight? I think Jay covered it quite well.
Yeah, a great explanation, Jay. It's a great scientific answer. Sometimes when I'm doing training, the best way I like to do it is take the Gore-Tex jacket. In the Gore-Tex jacket, you're obviously paying for a membrane that is keeping you waterproof. During your activities, it's vapor permeable as well. Everybody recognises that. But also it's wind resistant, which is probably where the best explanation of the air permeability versus vapor. So while you're doing your activity in your Gore-Tex jacket, whatever it may be, even if it's golf, some people might not think it's very strenuous. It depends how many times you're in the bunker. But you do have the breathability of the Gore-Tex jacket. And if it's windy, if you're playing links golf or you're up on the top of the hill, it will protect you from that wind as well. So that's the way, that's probably the easiest way to get around your head. But Jay, it's a great answer you've given. I think Adam's actually got a good explanation of a football net.
I thought you were going to mention that, Ian. I assume you're on about the one I used the other day with the football goal. So if you take a football and you kick it into the football net, the ball's not going to pass through. But if you used a golf ball or tennis ball, they would pass through the net. So what we're doing with membranes is quite similar, allowing certain molecules to pass through, such as if we want vapor to pass through, allowing them to go through. If we don't want air to pass through, we'll restrict those molecules in a similar way to that analogy that I've just used.
There you go. We do like our analogies because we use them to make sure that we understand the products as well. Thanks very much, guys. Ian, if I could come to you, we've got a question through from on YouTube from Marina Phillips. What do you feel are the biggest threats to the construction industry?
Yeah, it's a good question. Yeah. In the construction industry, I assume it's the same in other industries, we're always looking at threats. Sometimes spend too much time on the threats rather than the opportunities, but it depends on whether your glass is half full or half empty. Yeah, there's lots of threats in the construction industry. And what I like about the construction industry is it's an ability to adapt. You saw that in the COVID crisis, the construction industry really raised its game and overcome a lot of difficulties, building hospitals, etc. So there's a lot of threats. Climate change, regulations are all threats that we're constantly worried about. You know, climate change, increased rain potential. I've even heard of a wind drought. Certainly that's not the case in Scotland, but there is such a thing as a wind drought, and I see the logic of it. So there's lots of threats. I think fundamentally one of the threats holistically as an industry is training and actually attracting people into the industry. Attracting young men and women into the industry is a real challenge. Would you believe some school leavers don't think construction industry is very sexy? Don't understand it, but you know, it is. And you know, computering and accounting and all these kind of things are really interesting. To me, I think construction industry is fantastic, and we need to encourage that young generation coming in and attracting them and train them as well. Once they're here, train them. We do the toolbox talks. Pam, you and Joe went up this week to do some training. Yeah. And it's well received by even the older generation in the construction industry. You know, So they like learning, and we need to embrace that as best as possible. So that would be one of the biggest threats I would see.
Brilliant, thank you. Absolutely. Jay, please.
So just in addition to that, and it's not so much a threat, but a challenge. When we look at the complexities and the expectations of clients and what they want to drive for low energy and high performance dwellings, whatever they might be, it means that building designers and the chaps that go out and actually create these structures are having to fulfill the dreams of the clients. And sometimes that's a real challenge. If they want to get down to areas that are technically really advanced, we have to come up with strategies and processes that meet that requirement.
Yeah.
And I think at the moment, we've got this magic kind of panacea of having these really low U values, but how do we actually achieve that? The things that we see now that are challenging in 10 years time will be child's play. So we have to keep innovating and moving forward. And as Ian said, the pressure is on the skill sets within the people in the industry to innovate and drive that forward. Certainly from my perspective, it's what I see down here from a specification route is fulfilling the expectations of clients when they are so refined and educated before they've had that first kind of meeting and dialogue.
Yeah, it's a really good point, actually, Jay. You're absolutely right. Adam, did you want to add something in there? Sorry, the hand.
Yeah, I was just going to say that I've heard a lot of discussions lately about the construction industry and how it's quite an aging workforce. I think there's a lot of people between the age of 50 and 60, which means retirement is probably the next plan. So we need to, there's a big drive at the moment to try and encourage more funding, more education, and get people into this industry. But yeah, definitely.
Great answer. It's absolutely right, and I totally agree. You know, that sort of bridging the performance gap has been buzzwords for years, but it's still there. It's trying to take what's drawn on paper and putting on site, and encouraging the right people into the right mindset is really hard. But hopefully, we can overcome it as an industry together. Okay, let's move on. I've got a question. Well, I'll come to you for this one. It was on YouTube from Daniel Simpson. Shouldn't the industry be using A-rated membranes in high-rise buildings?
Good question, very good question, and probably, yeah. I mean, obviously the answer is going to be yes, but I'm gonna caveat that as well, and hopefully not get shot down in flames. First and foremost, you need to look at the primary function of that membrane. So yes, we want the best products, the best technical products, and the best fire performing products. Fire performance is always going to be paramount, especially when we're looking at the likes of relative high-rise buildings. But we also need to make sure the membrane is going to function in its desired as its desired function in what it is. So as an example, if we look at the outside of the structure, we've got a breathable vapor permeable membrane. We need to make sure that first and foremost it's able to carry out that function rather than sort of get too bogged down in some of the other nitty-gritty elements as well. Obviously, when we look at high-rise, fire performance is always going to be very, very important. But if that membrane doesn't have it will meet the criteria set out in BS 5250, then you're probably better off without one than sort of putting one in just for the sake of it being A-rated. And that's not to say that A-rated membranes don't achieve or don't comply with BS 5250. Most of them, or a lot of them, do. But we have certainly seen in the past that some of them haven't. They've been quite a sort of quick fix. A-rated products were needed, quick, we need to get them in, and they were started to be specified, and they weren't necessarily kind of doing the function they were desired for. So we need to be very, very careful. We should also consider the position of the membrane and also its makeup. Most membranes are very, very low calorific value, but just simply because of their nature. They're quite thin, they're quite lightweight, and if we look at an external facade, which tends to be the kind of major issue for fire performance, the membrane's normally put between a product such as an A-rated sheathing board and then sort of an insulation to the outside of that, which is also A-rated, so it's quite well protected in that facade as well. I guess I'll be pushing towards, we should really be looking at and testing products in their actual final environment, rather than just saying this product has this product has that, we'll put them together and that will be fine. So I think we need to understand a lot more through wall data, through wall testing. I think that's really, really important. Again, I'd say we always want to make sure we strive to specify that the highest or best performing products that are available to the market. So we just need to make sure that whenever we're specifying products, that they can primarily, to carry out the function they're designed to do. if we're looking at airtightness as a primary focus for a specification, let's make sure we tick that box first and foremost, and then make sure we carry out and comply with the latest building regulations.
Yeah, some great points there, Will. Thank you. Adam, you're not getting off with your goalpost analogy. Next question for you, if that's okay. Another one coming from YouTube there. We've got Linda Young asking, what is an EPD?
Yes, EPDs, something that's certainly becoming more popular at the moment. So EPD stands for Environmental Product Declaration, and they're a document that's going to demonstrate the environmental impact of that product over their lifetime. So you do a whole life cycle assessment to assess the environmental footprint of that product, and then that life cycle assessment forms part of your EPD document. Typically, they last for about 5 years. They're independently verified, and they'll be generated accordingly to the relevant standards, which is a number of them that has to conform to. I think that the reason they're becoming more popular, although they're not part of the regulation at the moment, is because they can feed into that whole building assessment a part of the scheme, and that helps the designer give a couple of options when looking at products in particular. So if your primary focus is to look at the environmental performance of your building and your project, these EPDs can certainly help when you put them into your building assessment for each product. So yeah.
Lovely, thanks, Adam. If we can go, we had a question on YouTube early on from Ryan. Ian, could I ask you to answer this one if possible, please? Ryan's asked, HES are given funding of £10,000, 2.5 thousand loan and £7.5 thousand grant for wall insulation. I own a traditional stone home, many of us do, and he's keen to use space therm wall liner. Do you have knowledge if this meets the criteria?
Yeah, it's a good question, Ryan. Without being predictable, it depends. Probably depends on what the HES grant is and what it stipulates. A lot of these grants require third-party certification. Even dare I say it, BBA, but there is no BBA or third-party certification for the wall liner. So if it does require the third-party certification, then wall liner wouldn't meet that criteria, which is unfortunate because it is a very good product and it would provide a lot of benefits. But with the red tape that might be required on the HES grant, you might need that bit of paper that goes with it, which arguably isn't as important as the performance. But unfortunately, that's where we are.
Thanks, Ian. Yeah, it's quite difficult when we get asked a bit about grant funding and technical, and it's a difficult one because quite often it relates to the actual installers that you use as well, whether you can actually tap into that funding. So although you could get somebody independently that you know and trust in your local area, if they're not looped into that funding, it can be difficult to attach it as well. So I think it's definitely, you need to kind of look a bit more into the criteria and the limitations of it, isn't it?
Yeah.
Yeah.
Sorry, Pam.
Thanks, Ian. Sorry, Adam.
Yeah, I was just I think that there's a lot of requirements for a lot of these grants. You'll find that, again, approved installers that need to be trained, they might have approved systems, which potentially could include some of our space firm products. So if that's something that they are trained on and comfortable with and get the grant for, you might be able to access it via that way. But yeah, there's a whole number of things to take into consideration there.
Yeah, brilliant, thank you. Jay, if I can come to you for this next question. We've had a DM in from Twitter from Daniel. He's asking, given the recent changes in Scotland in that all new homes should soon be built using passive house principles, do you expect to see similar low energy expectations in other parts of the country in the future?
Why am I answering this? You guys are in Scotland, it's over to you, surely. yeah.
Multidiscipline, Jay.
No, I'll say it unofficially. I shouldn't say it on a webinar, should I? But unofficially, I think, yes, there is certainly a drive down towards homes that are much more energy efficient, just from a sustainability perspective. I think if we look back 20 years ago, some of the challenges we see now didn't exist. We didn't think about airtightness. Dwellings were constructed to keep elements out and keep our stuff in. So when we think about the complexities and the challenges and the expectations of properties, yeah, I think it probably is a good guess to say things are going to start heading towards passive or similar type projects. When we add then the fact that, of course, gas boilers are going to be out of the window for new builds in 2025, we have to think about how energy is used, how energy is used in homes. Without going sort of on my political rant about it, but I think when you look at this whole drive we have with how, let's be honest, energy has been weaponized lately, if we can find a way of coming away from the national grid so that we are more responsible users of energy in a holistic insular sense per property, then of course passive is a really good application tool to drive towards that. So even if the plan isn't necessarily to go right to full passive sign off, I think using those principles contained within that plan is a really good strategy to walk towards. Absolutely. So yes, I think the unofficial answer would be I would expect south of the border, Pam, and south of you guys, we're going to start seeing a lot more and copying what you guys are already starting to do in Scotland. Absolutely.
Yeah, absolutely. Thanks for that.
I think that it's a great answer, Jay. Yeah, Scotland's heading towards that passive house side of things. I think passive house is great. The principles are great. I'm just not sure how it's going to be rolled out through big developments. Yeah, I was lucky enough to see a development in Lockerbie. At that time, it was the biggest development in Scotland, which was 14 houses. Now, Scotland builds a lot more than 14 houses, and that's the difficulty of how do we actually harness that. I like the low energy principles. I actually prefer the low energy principles rather than passive house because of the certification and the paperwork that goes with passive house. If you had the principles of low energy and the principles of that, I think that's a better way to go. I don't want to get too political between Scotland and England and any of the differences there. The rugby would have proven the superiority there recently, but the difference is passive's nice, but don't lose the effect of what you're actually trying to do. It's low energy and not spending a lot on energy, and what you do spend, save it as best as possible.
Yeah.
And airtightness is a great explanation of that.
Just to qualify, you'd know better than me, both of you, but I think that the Scottish is an equivalent to passive rather than full passive certification. So I think it has had some flexibility to allow for those things in. I'm not quite sure of the scope at the moment, but I think that's a lean towards those principles rather than full certification.
Yeah.
Yeah, you're right there, Jay. I was listening to a podcast, and I think it's going to be a sort of Scottish version of passive house, which is similar to what I think over in the USA have done. They've got the passive house standard, but then they've also got USA passive house, which is kind of their own variation to make it more achievable. But yeah.
Well, your turn.
Yeah, yes. Trying to be polite. I think the question for me would be, why wouldn't you want to? We've always trying to, for the last 20 years, ever since I've been in the industry, it's always been sort of, fabric first approach, making sure we get the actual building right. And I think I think it was brought up earlier, but there's still too large a gap between as designed to as built on site. And I think that first and foremost has got to be focused on. But obviously if we've got an actual design where we're trying to achieve and strive for the best possible performance of any building, then I don't see why we shouldn't always try and push the boundaries. The building regulations are kind of always seen as the sort of I guess what we're trying to achieve, trying to target, but there's nothing wrong with sort of stretching that and going further. And we've seen it recently. I had a conversation only this week regarding other countries, especially in the northern hemisphere in Europe, where airtightness isn't really seen as a key factor. It's not seen as a target to achieve because they're trying to build every single element as airtight as possible anyway. And I think that's kind of something that we should be looking at as a standard. Why are we trying to achieve a particular value when it comes to airtightness? Why aren't we trying to make every single element as airtight as we possibly can to make us have more control over that building? So yeah, passive house is great, and I get Ian's points as well. It's something to certainly to at least to kind of look at from a certification point of view, but certainly we should always be trying to strive for the best possible performance from our buildings, and why wouldn't we?
Absolutely, totally agree. Thank you, gents, for that good round table discussion there. Okay, Adam, can I come to you for the next question? This came in via Twitter again. Do you expect the modular market to grow in the UK? It's quite apt, seeing as I did a modular visit for you yesterday.
Thank you very much, Pam, for that. Yeah, I mean, I'm a business development manager looking after modular offsite, so yes, I do believe that. I think currently, I understand we're building around 15,000 modular homes in the UK, but we certainly got the capability to construct a lot more in this country. There's some quotes of thousands and thousands and more potentially. And I think there's a lot of advantages to modular construction, which is why I think we're going to see it become more popular. We're going to see it grow in the UK from faster completion time is compared to a traditional build, and then also potentially being more sustainable type of construction. There's a range of environmental benefits to building offsite, so that they're obviously going to enhance the growth. We've also got to think about the big demand in the UK for the housing market. There's a huge amount of new builds required, and modular is going to help that come a lot quicker and achieve those targets. And then, carrying on from what Will said a minute ago, and I think Pam, you mentioned it earlier, the performance gap, a big issue in this country. There's significant evidence to suggest that buildings, when they're completed, are not performing to what they anticipated during the design stage. Now, in my mind, in a factory environment, it's more controlled. You're going to get a more precise installation, and that's going to give a better consistent quality of construction, and that's going to help reduce the performance gap. So I certainly see it as the way forward, taking all that into consideration, and yeah, I can see the market growing.
Thanks, Adam, and apologies, that message was from Susanna. Sorry, I forgot to add the name there. Ian, there's a couple come in on YouTube and by email relating to roof shields. So seeing as I know how much you love roof shield, if I could come to you for both of these ones. If we go with the YouTube question from Heather Quinn, can the roof shield breather membrane be laid on a low roof pitch? And if so, how low a pitch would it still work efficiently at?
Yep, good question, Heather. It's a one that we get quite a lot in the technical desk. Roof shield's great, as Pam says. I think I'm not the only one in the company that loves roof shield. Yes, it's a great product, but it's not good enough to define the rules of physics. And when you get to low slope roofs, you have to be very careful. So any roofing underlay will be struggling to get less than 12.5 degrees. And similar, BS 5534 will tell you how big the overlap should be. So at 12.5 degrees, you're 225 gap overlap. So you have to be careful of that. But it's fundamentally the outer layer will decide quite a lot of the rules of your engagement in your pitched roof. It all depends on, I'll use that word again, all depends on that outer covering. A lot of outer coverings are not suitable for low slope. And when I'm saying low slope, I'm meaning 12.5 degrees. So you've got to be careful of that. But even with that, you have to be sure that the outer covering can be used at that level. And then is the underlay suitable for that? There are some very good low slope solutions on the market that deal with the problems of the overlap and the jointing. We recently had visitors visit us at Proctor's that gave us the benefits of a rigid underlay, of which there is a European standard for rigid underlays, which is effectively like a wriggly tin that goes underneath instead of the underlay. And that ensures that you've got the water tightness that's required. So in answer to you, Heather, yeah, roof shield can be used at low slope, but not lower than 12.5 degrees without further underlays.
I think it's also worth being aware as well, Heather, the type of tile that might constitute, because there are a few coming out in the market suitable for very low slopes, but quite often they could be like a man-made resin bonded type tile to deal with the increased requirements for the water holdout, because you don't get the drainage off the surface quite as quickly. So the inverse issue with that is they might be deemed too airtight. So you need to be very careful about checking out any requirements for batten cavity ventilation between the top of the membrane and the underside of those tiles as well, just because they are that type of nature, just for what they want to do. Ian, if I can come to this one that came in from Robin Suter, why would I need to spend more money on a roofing underlay that is only secondary protection? Because obviously we love Roof Shield, it's a premium product.
It's another great question. And one that it doesn't need the word depends. It's something that Proctors get asked a lot. At Proctors, we provide solutions, and we don't claim to be the cheapest, and invariably we're not the cheapest, but what we do provide is a solution. Yes, the membrane is secondary protection, but it's not just secondary protection. Certainly not with Roof Shield. We've got vapor permeability, air permeability to manage that moisture in that cold pitched roof. So it's not just there as secondary protection. It's doing a lot more than that. And, you know, you get what you pay for. So you pay for Roof Shield, but what we provide there is a solution to the problem. Unfortunately, a lot of our products are not sold on aesthetics, and they're always hidden behind plasterboard or hidden behind tiles, but they're very vital to the building physics of that building. And we don't sell it on aesthetics. So, you know, you get what you pay for and you build into your fabric.
Thanks, Ian, for that. Jay, if I could come back to you, I've had a DM here from Matthew, who's saying, I'm planning to convert my loft. What advice can you give to ensure this doesn't create any issues with condensation? Great follow on from the Roof Shield ones.
Yeah, it's a valid point, and I'm guessing that you've done a bit of research to know about the complexity in terms of condensation in the roof space. If we think about a standard dwelling with a pitched roof, just to understand, the vapor drive typically through stack pressure pushes all that warm, moist air typically up into the void. Traditionally, of course, that will then be kind of vented out, sometimes just through gaps in the roof or some kind of ventilation strategy. So if you change that by putting a room up there, you have to think how that knocks on to the rest of the floors beneath. It's a very holistic process, as we mentioned earlier on. Without digging too deep into it, there's a number of challenges as outlined in BS 5250 2021. If you work by that set of guidelines, you've opened up the door for a whole lot more work, because you know, if you're keeping the same membrane or your underlay on the roof, of course, you then have to look at ABCLs at ceiling level. So one thing we'd advocate, as we've just mentioned earlier on, is to use a different type of membrane, some kind of different kind of underlay under the tiles themselves. And our Roof Shield is fantastic in that respect. So if you've got a concern about a buildup of moisture, the objective really is to get that out as quickly as possible. So Roof Shield does that really cleverly. So it allows that natural passage of moisture to exfiltrate through the building, up through the roof, without the need for any ventilation externally or any kind of vents in the soffit or the ridge. That also means that when looking at your ceiling level, you don't need to put any ABCL in there. So in one sense, just to come back to the point, yes, there may be some differences in cost between our membranes and other ones, but utilizing that also negates the need to then have the subsequent works that may have to be prescribed in BS 5250. So it's right thinking about that loft, all the vapor's going up, think about a strategy to get it out. So if you have some specific detailing and diagrams you want us to have a look at, ping it through to our technical department and they can give you specific advice for that space that you're working in.
I think it's important to identify as well in your lofts. It depends what you're using it for. If it's
Depends.
bedrooms, obviously, you know, it's minimal moisture, but if you're going to be putting an ensuite or a bathroom up there,
Yeah.
you are going to have to look at making sure that your ventilation strategy is right. Probably are going to want to use an AVCL in there, cut down on things like, we quite often see recessed lighting in loft conversions just because of the height. Be very careful with them because they can obviously be puncturing through and loading condensation into
Absolutely.
it. So, yeah, Jay's absolutely right. Pop us some details and we can help out with recommendations. Sorry, Adam, did I see a?
Yeah, I was just going to say, I suppose the other thing to consider is actually accommodating that insulation.
Yeah.
You know, loft spaces are very tight and you want to maximize that as much as possible. A lot of membranes require a 50 mm gap between the membrane and the insulation, along with potentially your drape as well, depending on your build, which means you're then losing a lot of space between your rafters, where you could maximize that with insulation. Roof shield, in particular, doesn't suffer from that sort of what we call tenting, where moisture will seep through onto the insulation in a similar way that happens in a tent when you wake up in the morning and bang your head. So you can actually put more insulation between those rafters, maximize that 50 mm gap, and utilize more space in your loft space on there as well.
Absolutely. And I think as well, just to not forget our lovely other favourite product, space therm, it can be really useful to line underneath your rafters. So you can utilise it along with other types of insulation, but use it to line the rafters to prevent cold bridging and give you a little bit more head height. So we've got quite a few areas that we can help you with in the specification, and knowing how they all work together is really useful. Well, we've not heard from you for a while. We've got another question here from Ruben. Came in through DM. It's a great one because it's back on this still the sort of membrane side. Isn't a membrane just a membrane? Something we get asked quite a lot. What are your thoughts?
Thanks, Ruben. To be fair, yeah, I think my trusted colleagues have probably gone through a lot of this already, but I get it. I assume, yeah, we can set aside waterproofing membranes for the time being, such as flat roof and waterproofing membranes, and just look at more construction membranes and the differences between those, I guess. Yeah, if only it was that simple that they all were the same or similar, but no, not at all. They're probably, and I think this has just been said, but membranes aren't exciting products because they're not kind of, you know, going to be like an external aesthetic of the building. However, they're really important, and what's more important is making sure you specify the right membrane in the right location. I'm just thinking here, if we sort of go through a real basic house, if we look at a floor, you know, we're going to have a DPM, a damp-proof membrane. We're probably even going to have a VCL. We may even have a separating layer in there. There's three membranes that you could potentially use in the ground floor, which are very, very different from each other and have very different properties. The separating layer could be quite basic. It could be even a paper type membrane, just to try and keep street away from insulation and so forth. So yeah, just in that one application, you can see we've got quite a variance in products. If we move on to the wall, there's probably even more variances. We tend to find we're going to have a VCL on the warmer side of the structure. That's obviously going to have very, very different properties to a vapor permeable membrane, which is going to be on the colder side of the structure. The VCL is going to help to slow down that vapor drive and hopefully try and restrict the amount of vapor that's passing through that wall. And obviously the breathable membranes can have several functions. Yes, it could act as a secondary waterproofing layer, which can be quite important. It's going to allow the wall to breathe. If we simply go and put a VCL in the position of a breather membrane, we could essentially end up sort of creating a moisture trap, which might not even be a problem for a few years until it's kind of too late and the damage has already been done. So we do need to make sure that specifications is correct here. We also hear more about wind membranes recently as well, where maybe we have open jointed or ventilated cavity, where there might be quite a bit of air movement, and we're trying to prevent air movement between the wall, and we simply just need a product which is going to prevent that movement of air. So again, that could potentially have different properties. I think where sometimes confusion happens with membranes is they can have similar functions as well, such as airtightness. So a VCL can be airtight, a vapor permeable membrane can be airtight, and we look at airtightness lines, and it becomes confusing as to what do I need? I need an airtight membrane. Well, that should be the VCL, but my airtightness line is drawn to the outside. What do I do? So yeah, that's again can cause a bit of confusion, but again, it's making sure that we do understand that a membrane isn't just a membrane. And then we've gone to pitch roofing, which, to be fair, Ian's just touched on. We have again, we're going to have probably a VCL to the warmer side of the structure, and then we could have an air open or an airtight membrane, which could end up changing the way we sort of specify our ventilation system in the roof. So yeah, in answer to the question, no, they're not all the same, and it can be really perplexing because in essence you've got hundreds of different types of membranes with hundreds of different types of performing criteria, but the good news is that's what we're here for. We can give an honest appraisal on a particular build-up. We can use the technical equipment that we have with regards to condensation risk analysis and dynamic numerical simulation to help make sure that things are specified in the correct place. So yeah, talk to us.
Thanks, Will. Ian, sorry, yeah.
Sorry, great answer, Will. But who said membranes are not exciting?
Yeah, I knew as soon as I said that.
Membranes are exciting.
Someone's going to be like, what do you mean? What do you mean they're not exciting? They're not exciting to all, I should say, maybe,
You must come to my dinner parties. They're very interesting.
I was just going to say to anybody that's watching, we're probably the worst people to ever invite to a party because we can talk about membranes for hours. So if you see us on a list, probably just avoid us.
It's a really, really good point. We'll bore you. Let's move slightly away from membranes just for a moment. Ian, could I come to you for this one? It's an email we got in from Chloe Jones. It's a great question. Should there be green mortgages? Get my teeth in. Green mortgages to encourage homeowners to buy new homes?
Yeah, it's a great point that's been made there. Green mortgages, I've done that recently. I like the principles of it, that new houses are more energy efficient, spend less money on your utility bills, and therefore it should be easier to pay your mortgage, and therefore that should be reflected in your affordability calculations when you're asking for a mortgage. We'll not get Adam on about how cheap his house is to heat, but that is not even worthy of dinner party discussions. But my house is a stone built house, and I would love for it to be more energy efficient. And I think it's not necessarily new build that should be concentrated on. There should be something that allows people to get mortgages, whether it be new build or refurbishment, on energy efficient houses. Whether that be dealt with through EPCs that would allow the affordability of existing houses and new build houses to be easier to get a mortgage on, because that affordability of the utility bills is taken into consideration. So yeah, I love the idea, but I don't think it should only be new homes that should be applicable to it.
No, I mean, I have to admit, I'm with you on that one, Ian. What worries me slightly is some of the move over the next few years that we're going to see where people aren't going to be able to rent or lease houses or get mortgages on houses, existing stock that is not up to specification, and that could be really, really detrimental for some new buyers, or for the housing shortage that there is at the moment. We're either going to see a glut where people are going to be trying to sell their houses because they can't afford to keep them, or we're going to see a real problem where people are trying to upgrade their houses and there's just not the installers and the qualified people there to bring them up to speed. So it's kind of quite a difficult one. I understand the need, but it's very much a balancing act, isn't it, to try and make sure that everything works together and people don't get penalised and we don't end up with hundreds and thousands of old buildings left to rot and decay because nobody can afford to bring them up to spec or buy them.
I guess the problem is, though, that if that is the driver, the difficulty is that these beautiful old houses that I would say are beautiful because they're old stone buildings, will get demolished and replaced with new energy efficient buildings. So it might be just as beautiful to some, but you're kind of losing the character of many villages and towns by doing that.
It's a difficult one, isn't it? Yeah. Okay, and we're getting close to the last few questions here. So if there's anybody else got anything to ask, please get them in soon. Jay, can I come to you? We've had an email from Rachel Forneth. I'm currently working on a project where we need to improve thermal performance of an existing dwelling. How apt. She's saying that they're assuming a brick thickness of 250 millimeters, and they're looking at an internal insulation system. We had allowed for a 25 mil batten and a 57.5 mil insulation board with plaster skim finish.
Mm-hmm.
This achieves a U value of 0.3, which is allowed for an energy and sustainability report. However, can we improve on this in line with Part L requirements, limiting U value calculations for walls to 0.26? There's a lot in there.
I'll focus on the last bit because if we just use the analogy of having an existing building, apologies about not writing that down. Did you say 0.26 as a U value?
Yeah, so
Part L is driving down to, we'd be seeing levels below 0.18. And I think if you look at passive 0.14, driving down and down,
yeah.
talking about that Scottish situation earlier, that there is this drive down to make buildings more efficient. Yeah, it's a bit of this chicken and the egg thing, because if we have this objective and we don't have the tools to get there, how do we get these two forces to meet? That drives innovation. So if we look at the traditional kind of processes we might have used to put internal wall insulation, they will unfortunately miss that number by quite a long way. So I can't remember who mentioned, I think it was Adam talking about space therm earlier on. It's an aerogel. So for any of you that are watching, just Wikipedia aerogel, it's an incredible material. And I won't bore you with a story about it, but it's quite comical how it first came about, but it's now got this really amazing commercial application. So the premise behind that is to achieve better, and really, by better, I mean significantly better low U values compared to traditional materials without maximizing wall thickness. And in most situations, you can make that profile much thinner. So if there is an implication here where you want to retain a building without sacrificing that internal space, then it means you kind of have to revisit the traditional process. So in this sort of situation, I'd say ultimately get in touch again, send us the details, and we'll come back with some comparative values between how that wall perhaps is functioning now. You said 0.3, is that right?
What they've specified at the moment is reaching 0.3, but I think they're looking just to maybe try and push the envelope a little bit further. If we change that spec and introduce, for example, some different types of space therm, aerogel insulation, we can then give a comparison. But I think through all of that, whatever you do when you've got an existing wall, as is detailed in BS 525021, please ensure you carry out some kind of hygrothermal analysis to make sure that you don't inadvertently create one problem. Let's not forget, of course, that dwellings years ago, we didn't have to think about airtightness or moisture control. Buildings just breathe and let all these big gaps and drafts and gaps and everything else come through. So by sealing all those in, we have to think about the air and moisture really differently. So I'd say get in touch, let us carry out some analysis for you. But just as a little side note, if you're having battening, I think you mentioned in that, it's often worth putting a piece of space therm blanket in behind that to deal with the repeating cold bridging issue. It's only a very notional figure, but if you want to get down to the 0.26, 0.18, you need to address those, because those would exponentially put the U values back up again. So I'd just say get in touch. It's a very complex area, but don't default to your normal processes. Perhaps look at some innovative new materials such as space therm. Yeah, Adam.
Yeah, I think we've spoken a lot there, especially about refurbishment and that. So I think it's worth probably mentioning there are probably a lot of people thinking of a new build or only a self-build project where they're going to go for passive house standard. But there is the NFIT standard out there, which we haven't mentioned, which is like the passive house principles, but has a little bit of wiggle room to make it possible for retrofitting a lot of these properties to very good standards. I think we did a great webinar on it a few months ago, so it's worth going and watching that again. But it might be something to consider, rather than looking to get a new property or something, let's focus on that standard for retrofit.
Yeah, and the NFIT backstop U values aren't too onerous for walls. They are around the 0.3 as the sort of the minimum, and because we know around about that, you're not going to get problems with trapping moisture in the wall. Rachel, if you want, there are some webinars that we've done before, if you haven't seen them before, on retrofitting, challenges of retrofitting old buildings. might be worthwhile going back into them and getting a few hints and tips from that, as well as the Interfit webinar that Adam mentioned as well. So we've got those resources on our website. Okay, last couple of questions. Ian, can I come to you? There's one on you from YouTube, the YouTube feed from Scotty W. Are you finding any new challenges when specifiers are employing inset PV panels over breather membranes on pitched roof? Now, I know we don't get asked that a lot in technical, but I know you've been speaking to a few people. But...
Yeah, we've, thanks, Pat, and thanks, Scotty. Whether we're finding any new challenges, not particularly. We are asked occasionally about PV panels, as long as they're carefully installed. And when I say carefully, I mean with adequate ventilation below the panel, then there shouldn't be any real challenges as such. We have been dealing with some of the major tile manufacturers about PV panels as well, where they've used a roof shield in their trials, have gone successful. I have been in meetings where they've talked about the potential build-up of heat below the PV panels, which is something again that they need to take into consideration. But personally, we haven't come across any problems with PV panels. You should probably just speak to us and ask if you want. If you're in any doubt, then send us the drawings and we'll have a look at it and see whether we think that it's going to be suitable or not.
I think, in my point of view, it's making sure things like any penetration through the roof is making sure your flashings and everything like that around it are in place, so that you're not sort of adding extra moisture load through onto those underlays that are your secondary protection layer. And being aware that you can't just put a facade membrane necessarily underneath it to compensate for UV getting through, because those products quite often, or more often than not permeable enough for a roofing application. So it's just being careful that everything is working together and holistically.
That's a good point.
Okay, Ian, I'm going to stick with you. There's quite a controversial one here. Maybe some of the other ones might want to jump in and make some comments. This has come in from Maureen by email. And the government have put a 6-week deadline on developers to sign up to legal agreements that commit them to pay for unsafe building repairs. Do the panel think this is fair?
If I could take that one.
Yeah.
It's a really good question. It's a really hard one for us to answer. So, you know, Grenfell was a great tragedy, of which I think the construction industry is still reeling from. There's a lot of things went wrong at that. And I think it's put the industry in a bit of shame of some of the things that have come out from investigation of that Grenfell inquiry. I think one of the difficulties is that that building was built allegedly in good faith, well, presumably in good faith, to meet the building regulations. Whether there's a lot of things behind that cladding that's wrong, from potentially the insulation to the install to the certification. Everybody in that inquiry has been hit by not doing the right things, building control, etc. So it's difficult for us to comment and say it's because of that. There was a lot of things went wrong with that job. To say that developers should pay for that, I think is unfair. Because I don't think the developers were doing necessarily anything wrong. They were just complying with the building regulations. And whether they did it right or wrong, installed it right or wrong, they only were meeting the regulations at the time. And I think the government had plenty of opportunities to change the regulations before that. And they knew there was a problem there, but never addressed it. In my opinion, this is not the Proctor line necessarily, but in my opinion. And I think that needs to be addressed rather than the developer having to pay the bill. It's too easy to say that the developer pays, in my opinion. So that's what I would think.
Difficult one, isn't it? Yeah.
Yeah.
Jay.
Can I just add, we mentioned earlier on, somebody mentioned about some of our membranes perhaps being more expensive than competitors, and they're absolutely right in that respect. But what we're trying to do as a business is try and future-proof. So it isn't for us just a case of supplying material and forgetting about that, how that's applied on site. For us, we work very much in line with our customers right from the specification process. And I'd implore any of you who are watching to get in touch with our technical team, because they are absolute gurus when it comes to knowing that the complexities of a project. And you can delegate a lot of your work to them, can't they, Pam? But then from that point on, we then work really closely from not just the delivery, but also the installation. So we document that process on site to make sure that goods are installed in accordance with our recommendations and they are appropriate for use against the adjacent materials. It creates this dossier, you have this document that validates that things are done properly. And that's an audit that can then be put forward to building control or other people to ensure that the right measures are being taken. So in answer, one of the reasons we're more expensive is that we don't just supply material, we supply a service, notwithstanding, of course, not the installation, but we are there to carry out really a survey to make sure things are done appropriately and safely for the future of the buildings and its occupants.
Absolutely. Thank you. I think I'm down to the last question, unless there's any more that have come in during this one. Well, you've got off easily because I'm asking this one to Adam, but you may want to jump in on it. Adam, just because I know how much you love roof shield, wrap tight, sorry, roof shield as well, but wrap tight. Email in from Joe Clayton. I am interested in using wrap tight, but it looks difficult to install.
Could be a good question for yourself after yesterday, to be honest, Pam. Yeah, it's quite interesting hearing that, actually, because we get, it's kind of split 50-50. Some people say, oh, it looks easy to install, and kind of don't use us and crack on without our help. But then we get others that say, oh, it looks potentially challenging. But one thing I will say, we have a lot of repeat customers, specifiers and installers. So that tells us once people have used it for the first time, that they continue to use it on future projects, which is certainly reassuring from that point of view. And I can personally say it's simple to install. I've installed it myself, and not just a little section, a whole timber frame extension with difficult window openings and everything. So I can say it is simple to install. But like everything, we can certainly make it unnecessarily challenging for ourselves. We just need to prevent that, and we're here to help with that. We can come to site, we can offer toolbox talks, we can come through the installation process and take photos, do reports on the installed product, and hold your hand all the way through it, so we can make it easier. I actually had one this week. We went to site, the contractors picked up the big 1.5 meter by 50 meter membrane and used to installing horizontally, so they picked it up and they're trying to peel the release liner on and stick it on, and made it all quite challenging for themselves. I then showed them, well, hang on, let's look at doing this vertically. Let's use the weight of the membrane to keep it nice and taut, line it up, stick on sort of 200 mil section, and then slowly just peel the release liner off. Not only then, it became a lot quicker, simpler, but also we got better quality, and they were much more happier. I still said, look, we can use it horizontally, so under the windows, those sections, we can do a smaller, manageable piece. And the contractor said to me, it was like Tetris, putting all the little pieces together. And that's exactly it. Take a look back, take a step back, look at your substrate, think of how it's all going to fit together, what bits are going to be challenging, maybe do all your little fiddly details with smaller pieces. So I'm going to use a 300 mil wide section for my windows, or 500 mil, detail all of that. Then you've got your big bulk of facade to use vertical 1.5 meter rolls, and make it a lot easier for yourselves. So sometimes just a bit of prep earlier on helps a long way to make it easier. But we're here to help on your projects.
Absolutely.
Yeah, Adam's right. He's pretty much, there's not a lot I can add to that. Preparation's key. Make sure, we see it so many times where people kind of rushing in with wrap tight, trying to install it, just get it on the wall. And we appreciate that time constraints are always in place. But if we just take that time at the beginning to sort of prep exactly where we're looking at installing the products and how identify all the tricky areas, that's actually going to save time in the long run, because you're not having to sort of replace and repair. So definitely make sure that you take the time to prep.
Definitely, it really is. definitely. It's thinking about how it goes and not being afraid to challenge how the best way to do it. So as Adam said, I went up and did a site visit from yesterday, and we did exactly that. We talked through the applications, we talked through the tricky bits, and what we started thinking about was totally different by the end of the chat through.
Yeah.
So, but they know, they understand how to use it. So it's not difficult. It's a great product to work with. It really is. If I can install it, anybody can.
I think it's also an opportunity to promote that we can pre-cut sizes. So if you want anything under the 1.5, 300, 500 mil, 1 meter, we can pre-cut that. So that also will speed up and improve the installation process.
Really useful if you've got repeating openings, etc., and for modular and everything like that.
Yeah.
Okay, huge thanks to everybody. Hopefully I've got all the questions in. If we've missed anything or anybody's got anything else, please do get in touch. You can email us at webinar@proctorgroup.com. You can access all the information of all our products online and in our members area. You can get in touch with us through our web forms, etc. there as well. Just leaves me to say a huge thank you to our panel today, to Ian, Will, Jay and Adam, and thank you to everybody that tuned in and gave us questions. Huge thanks to the backstage crew keeping me right and dampening my panic this morning, and they really do ensure the smooth running of all these webinars. Date for your diary, our next webinar will take place at the usual time of 10 AM, and that's on Friday the 31st of March. That's the last Friday in March. In this one, we're going to take a look at the history of our Roof Shield product, our Roof Shield air and vapor permeable underlay. And we're going to look at a number of our favourite projects over the year, case studies, and just how it came into being. So that actually should be a really interesting one for anybody that's interested in knowing how Roof Shields developed and stayed at the forefront for the last 25, 26, almost 27 years. The membrane itself hasn't changed a lot, but obviously the legislation, how it's used, etc., has changed. So we'll look at the basis of those, and also how our range and applications have expanded since it was introduced in 1996. So registration should now or shortly be ready to go at proctorgroup.com/webinar. I think that just leaves me to say thank you again to everyone for joining us, and I hope you all have a lovely weekend. Goodbye.
Thanks, everyone. Bye.
Yeah, everyone.
Thank you.